crisps were invented when a customer sent back his fried potatoes, complaining the slices were too thick. The insulted chef cut them paper thin and fried them to a crisp. So pride, not ingenuity, was the mother of this invention. Crisps have to be made with fresh potatoes, no more than 24 hours old, otherwise the crisps would have black spots. After a brushing machine removes the dirt, the potatoes travel along a water canal to the peeler. The peeler's abrasive rollers work their magic until the skins come off. This machine can peel 5,500 kilos of potatoes per hour. Next, the potatoes are separated by size. The small ones fall below to be rinsed. The larger ones stay on top to be cut. They then fall down to the rinser too. Next, the potatoes go through slicers. The slicer's blades are adjustable and can be set to different thicknesses or shapes for the ribbed crisp lovers amongst us. The centrifugal force created by the spinning throws the potatoes against the sharp blades. When making regular crisps, an average potato yields 36 crisps. Finally, it's time to wash the potato slices. They spin inside a giant barrel of cold, fresh water for about a minute. Then the slices pass under an air blower to dry the excess water. The fryer contains oil boiling at 370 degrees Fahrenheit. It takes just 3 minutes to fry the potato slices. As the crisps exit the fryer on the conveyor belt, the excess oil drips off. Next comes a shower of salt. The crisps move on to the sorter, where an electronic camera identifies any crisps that have brown spots or other defects. The camera then triggers the thin pipe directly above to blow the offending crisp off the conveyor with a burst of air. Elsewhere in the factory, they're making another popular snack food, puffed cheese balls. First they take corn flour and mix it with water. An extrusion machine forces the mixture through round holes. When the snake-like stream comes out of the other end, a knife cuts them into pieces. The heat in the machine then causes the flour in those pieces to explode, creating slightly curled puffs. They spray the puffs with a mixture of oil, powdered cheese and natural colourings, and a revolving drum mixes it all together. Back in the crisp department, the potato crisps are sprayed with powdered seasoning, which simulate flavours such as barbecue or salt and vinegar. The next machine separates and weighs the portions to be packaged. Crisps drop into bags that are then heat sealed. It takes about 15 minutes to go from raw potato to crisp, a lot longer than it takes to eat them. A microprocessor is the brain inside a computer. It's made up of a microchip on an electronic card. Preparing the chip to be installed on the card is a delicate and precise operation. Scientists built the first computer in 1937, but it could only do algebra. The first general-purpose computer in 1946 was the size of 20 fridges. During the 1950s, transistors replaced bulky vacuum tubes. Then integrated circuits replaced transistors. But the biggest breakthrough came in 1971 with the microprocessor. All the components on one minuscule chip, making today's personal computer possible. We start with a ceramic square called a substrate. This will carry the microchip. A machine coats the substrate's surface with flux, a chemical that makes it sticky. This will hold the microchip in place until it's soldered. This facility receives the microchips ready-made with all the circuits in place. A microchip is placed on each substrate. An infrared light guides the machine to place the chip in precisely the right spot. A sample is pulled from the production line to further verify the positioning with a microscope. Next stop is the soldering oven at 360 degrees Celsius. The heat melts tiny beads of tin positioned on the chip, binding it to the substrate. Next, they prepare to solder an aluminium cap over each microchip. The cap has two functions: to protect the chip and to dissipate the heat the chip generates. A robotic arm picks up 4 caps at a time and positions them over the microchips. They go into a soldering oven at 150 degrees Celsius for about an hour. The next step is to create the electrical connections that will later link the microprocessor to the computer's electronic card. They start with tiny cylindrical pieces of tin called columns. A giant suctioning sieve vibrates the columns until they fall through the holes. This lines them up vertically so they can be attached to the substrate. A thick adhesive paste is spread that attaches the vertical columns from underneath. The chip-carrying substrate is positioned on the pasted columns. The result is a microchip with 1,000 connections. For even more connections, tin balls are used instead of columns because balls are sturdier and more reliable. They too go through a suctioning sieve. Only instead of paste, they're stuck on with flux, the same sticky chemical used earlier to position the microchip. The finished microchip unit goes into a bath of water and solvents to remove any excess flux and contaminants. Last stop is quality control testing, including 12 hours spent in an oven heated to 140 degrees Celsius. From here, the microprocessor unit goes to another factory where it's soldered onto an electronic card. The little brain is then ready to get to work.